Hello, everybody. We are going to move on now to the empirical rule and normal distribution. So, if you see AP Stat in your future, this is a big one. So, pay attention and stay with me. Even if it isn't in your future, that's okay. If you've heard about like grading on a curve, like those kind of expressions, this is where that comes from. So, the empirical rule, also known as our 68, 95, 99.7 rule, provides a quick estimate of the spread of data in a normal distribution if we are given the mean and the standard deviation. Okay? So specifically what the empirical rule states that for a normal distribution, and it will be stated whether or not it is a normal distributed data set, okay? It means that 68% of the data fall within one standard deviation from the mean. 95% fall within two standard deviations within the mean. And then almost all, which is why it's 99.7% of the data, fall within three standard deviations of the mean. Okay? A normal distribution is a bell curve. It looks like this. So here's a visual representation of what we just talked about. Okay? So it's a function that represents the distribution of many random variables as a symmetrical bell-shaped graph, okay? Where mu, that's what this is called, it's called a mu, is the population mean, okay? So when we were using like the bar on top, that was our sample mean. Now we're doing everything, okay? Our mu is population mean. And the numbers represent the number of standard deviations away from that. So you'll notice that the mu is always in the middle. And then if I go one standard deviation above or below, that's 68%. If I go two above and below, that's 95% of all of my data. And then three standard deviations above and below, that's going to be 99.7% of our data. Okay. Z-scores for a normal distribution, not a sample, this is just normal z-scores. These are the number of standard deviations away. So like this one is a z-score because it was one standard deviation away. So it just shows you how many away they are. They won't always be whole numbers. Today they will be, in the future they won't. But what we do is to find this, we take x is a value. We subtract the mu from it. Remember, that's our population mean. And then you divide it by the standard deviation. So this information will be given to you. So again, today, since you're being introduced, it's going to be the whole numbers every time. Next lesson, they're going to start not being whole numbers. And we're going to see how we can use our calculators actually to help us out. But that's next lesson. So today, introduction, trying to keep it simple. All right? Here we go. So we're going to draw and label our normal curve below. So what always goes in the middle? Our mu always goes in the middle. That's our mean. Okay? If we go one above, that is positive one standard deviation. If we go down, that's negative one standard deviation. Remember, positive just means up, negative just means down. It's a direction. Okay? If I go out one more, that's two standard deviations above, or it's two standard deviations below. And then one more time, that's going to be three standard deviations above or three standard deviations below. Now, each part of this has a certain percentage, right? If the empirical rule said between one above and one below is a total of 68%. Oops, sorry. Right? Which means just this one piece is 34 and this piece is 34. Because it's symmetric, it's cut in half. All right? All right, then it said if we went two above and below, this was what, 95%? Okay, so we got to remember, so 95 cut in half, let's see, 95 divided by 2 gives me 47.5, but I got to remember, like, all of this is going to be 47.5, right? I already have 34 there. So if I subtract 34, just this small little piece is going to be 13.5%. All right. And then going all the way, so 3 above and below. That gives us a total, trying to figure out where to write it, of 99.7%. Okay, so again, cutting that in half, 0.7 divided by 2 gives me 49.85. So from the middle all the way to here is going to be 49.85. But remember, I already have, 47.5% taken care of. So subtract 47.5. And this itty bitty piece is only going to cover 2.35% of my data. 2.35%. And what does that leave us with the end? Well, all the way across would have been 100%, right? From beginning to end. Well, if all the way across covers this half covers 49.85, well, half should be 50, right? So 50 minus 49.85 gives me 0.15%. It's what's left over in these little tails. Okay, if you add up all these values together, it does give you 100%. All right, so the percent of a shaded region represents the percent of data items that would fall in that region. It also represents the probability that a randomly selected item would fall in that shaded region of the curve. So that's how we're going to use it as well. All right, so you need to be able to know this. I will not give you these percents. Okay, as long as you can remember the 68, 95, 99, 7 rule, then you can figure out all this stuff, right? All you gotta do is just cut things in half, do simple adding, subtracting. You can fill in this curve. All right, so let's use it. Here we go. Example number 1. Using the picture, find the following of percents and shade the portion of the curve below that it represents. So right here, what is the probability that I have a value that is less than my mu plus 1 standard deviation? So any value that is less than or equal to my mu plus 1. All right, well, remember, my mu is in the middle. Plus 1 means right here. It wants to know what probability is it to find any value that is less than that. So that's going to be this entire part of my bell, right? Using the bell curve we just drew, I want you to look at it. Remember, all the way up to the middle, we know that's 50%, right? And then what did we say this little piece was right here? That little piece is 34%. So up to the halfway point is 50%, and then we're going to add on this 34%. So what is that? That's a total of 84%. Okay? Or 0.84 probability that our data is going to be less than mu plus 1 standard deviation. Okay? So again, sorry, I said this and didn't write it. We were finding the percentage of data that is less than 1 standard deviation to the right of the mean. Sorry, I said that and didn't write it. Okay, so adding up each of these pieces, which you could have done here, right? So lots of ways to do this. So we were going up to this point. So we could have added up all these together, 0.15, 235, 13.5, 34, 34. Or, again, because I know up to the middle is 50%, that's what I did my shortcut. I did my 50% and then plus my 34. Okay? So you can add things up individually, or if you can find shortcuts, definitely use them. All right, let's do another one. So now, what is the probability that we're going to have a value that is less than mu minus 2 standard deviation? So that wants to know what's the percentage of data that is the less than symbol. So we're less than Now it's 2 standard deviations, and since it's negative, we're going to go to the left. Okay, so remember this was my mu, 1, 2, so negative. So we're looking here, right, and below. So we're looking at that little piece, this little tail, okay? Going back to our bell curve, we know this piece was 0.15, right? And this little piece was 2.35. So I'm going to add those together. 0.15 plus 2.35% is going to give me a total of 2.5%. Okay, makes sense. It's a very small piece of our data. So that little tail is going to be 2.5%. All right. Here we go. Part C, excuse me. Now what's the probability of finding a value that is greater than mu? So what does that represent? Okay, well, that wants to know percentage of data that is now more than, right, because it's greater. More than mu is our mean. And where is our mean? It's in the middle. So if we're trying to find it to be greater than, oh, hold on, there we go. So greater than my mean, that's this piece of my bell curve. Isn't that just the top half? So what is the top half? That is 50%. Why that blank is so big. So that was half of my data, that is 50%. And again, you could have gone back to that original bell curve and added up each of these individual percentages, which is 34, 13.5, 2.35, and 0.15, which also does give you 50. So it is 50% of our data. All right, one more until I'm going to have you try some on your own. This one, okay, so this one we're going in between two values. So what's the percentage of being, let's see, a value that is greater than my mu minus 1, but also less than my mu plus 2. Okay, so we're in between one standard deviation to the left, right? That's to go down. So that's down here. And we're going to be, and we're 2 standard deviations to the right. Because that's what plus means. So here's my mu. So here's plus 2. So we are looking for this region. All right, I'm going to go back to that bell curve that we labeled every single piece. These 3 regions, it was 34 plus 34, right? So 34, 34, and then this small piece was 13.5. So we're going to add those 3 together. And when I do that, we're going to get 81.5%. Okay, so we have 81.5%, and that's going to lie in between 1 standard deviation below and 2 standard deviations above. All right. It is now your turn, so I want you to shade the curves like we were doing, and I want you to find the percents. The first one is probability of a value being less than my mu plus 3. The second one is going to be the probability of being in between my mu minus 2 and the mu itself. So mu, remember, is just mean. Mu is the name of the symbol. All right, so pause the video, shade your bell curves, and find your percentages. All right, check your work with mine. So the first one, there's lots of different ways to do these. The first one I noticed it was almost the entire bell curve except for that last little piece on the end. So I did my 100% minus the piece we didn't include, which is the 0.15, and I got 99.85. You could have added them all up. You could have done the 68-95 rule and then added what was extra. Lots of ways to go about number 1. Number 2, we are in between -2 and then the mean itself. So those 2 sections were 13.5 and 34%, which gave me a total of 47.5%. Okay.
Here we go. We are almost there. All right. So now we're going to do a little bit of some context to it. Okay. So here we have an IQ test is standardized to a normal model. We're going to talk about IQ test a lot. Later, I'll give you a website to try to find your own and compare it to like celebrities and stuff. It is a standardized to normal model. So it fits the normal distribution curve. It has a mean of 100 and a standard deviation of 16. So with that information, I'm going to be able, so a mean of 100, standard deviation of 16. I'm going to be able to complete my curve. So that's what we're going to do first. We're going to clearly label it, showing my standard deviations away from my mean. So if my mean goes in the middle and my mean is 100, that means that this is now 100. That was my mu, right? And as we moved up, didn't we add our standard deviations to it? Plus 1, plus 2, plus 3. Well, my standard deviation is 16. 100 plus 16, this is now 116. This will be an IQ score of 132, and this shows an IQ score of 148, right? And then we do the same thing the other way, but we're going to go backwards. So we're actually going to subtract our standard deviation. So 100 minus 16 gives me 84. Minus 16 again gives me 68. And minus 16 again gives me 52. All right, and now we're going to answer some questions about it. In what interval would you expect 95% of our scores to be found? Well, with my empirical rule, my 95%, remember, it was within one standard deviation above and below, right? Those were each 34 percentages. That right there is 68. So that's not it yet. Then we had to go one more, 2 standard deviations above and below. That's what gave us our 95%. Okay, so with the empirical rule, using that, I will be between, so 95% of the population of IQ scores are going to fall between the IQ score of 68 and 132. All right. Next question, what percent of people should have an IQ score of above 116? Okay. I'm going to get rid of this so I can shade new stuff. Okay, so now we're going to look, what did it say? Above 116. So here's 116. We're looking above that. So this is just like the ones that we were just doing. So above that, we're going to add those pieces together. Okay. This little piece was what? 13.5. This was 2.35. And this was 0.15. So if we add all those together, we're going to get 16%. So only 16% of the population is going to have an IQ score of 116 or higher. All right. Clear off my curve. So now my next question. What percentage of people should have IQ scores between 68 and 84? All right, well, let's shade that little piece. Oh, yeah, 68 and 84. Okay, that's just that little chunk. If we go back to our empirical rule, just that region represented 13.5% of our data. Remember, these two were 34, and then those two were 13.5. So that's 13.5%. All right, and then what percent of people should have an IQ score above 132? All right, here's 132. So it looks like we have these small pieces on the side. This was 2.35%, and the little tail off the end we said was 0.15. So we put those together, and we have only 2.5 of the world's population should have an IQ score of 132 or higher. All right. So now it's time for you to try one. So here we're talking about the human female waist. measurements very normally. In other words, they fit a normal distribution curve with a mean of 70 centimeters and a standard deviation of 4.5. So I would like you to pause this, label your curve, and then come back. So don't answer A, B, C, and D yet. Just label your curve, pause, label, and then unpause. Make sure that's correct. And then if it is, then pause again and answer the questions A, B, C, and D. All right, so pause and label your curve. All right, so just check your labels, make sure those are correct. You should have your mean in the middle of 70. Standard deviation was 4.5, so when you moved to the right, you kept adding 4.5, and then when you moved to the left, you kept subtracting 4.5. So if you have these right, awesome. Now pause and do questions A, B, C, and D that match with this. Okay. Check your answers with mine. I tried to leave all the work I did up here so you could follow along. So between 68% of the measurements, that's one below and above my mu. So that's between 65.5 and 74.5 centimeters. A waist size above 79 centimeters, that's going to be those last two regions together, which is 2.5%. Waist measurements between 61 and 70 centimeters, so that's those two regions together. That's 13.5 plus 34 gives me 47.5%. And then percent of people should have a waist measurement below 61 centimeters. You add the last two regions, which actually matches with part B. This is just the bottom half versus the top half, and it is also 2.5%. All right, so we are done for today. So you have a worksheet to work on with all of our standard deviations and means are given to you, and the z-scores are the ones we're using are the ones that are labeled like we just did. Next time we come in here, I might ask you what percent of people have a waistline higher than 72 centimeters. So that's not one of my labels. Okay, so we will explore that the next time. So today we're going to stick with the whole numbers. And yep, you have a worksheet, work on that, and I'll see you next time.